All right, so let's check out some more derivatives here. And I'll be honest, a lot of this should be some familiar things. For example, this first part, you should be able to write these derivatives off the top of your head. So if you cannot, that's a problem. So hopefully you know all of these trig derivatives. And we're just going to combine this
Destiny Sims, please
with
come to attendance. Destiny Sims.
what we learned last week. So here are our trig derivatives. Okay, now let's look at number one. Find the derivative if f of x is that long thing. Well, what do we know? We know that I can take the derivative. When I see a minus sign or a plus, I can just go down the line and take the derivative. So I said, okay, well, I need to take the derivative of this thing. Well, what do you see with that thing? You see a product. So you're going to have to do the product rule with this first one. So let me do that. F prime of x, I'm just looking at this first term right here. So I'm going to take 4x as my first and sine of x as my second. So first times the derivative of the second plus the second times the derivative of the first. So I'm going to put that 4 in the front because I just like the look of it. So now that's that part. But then I have this second part. And I go, oh my gosh, I see another product. So I'm going to have to do the product rule again. Now let me make a suggestion on the minus. If you don't just, a lot of people tend to forget the big old parentheses. So it is my suggestion, when you have a minus in the middle, I'm going to make it a plus and tack on the negative with the 2x squared. So that when I do the product rule, I know I'm taking that minus into account. So I'm going to put plus. Now let's do the product rule again with the first and the second. First times the derivative of the second plus the second cosine of x times the derivative of the first would be negative 4x. Now let me just clean up. Well, hopefully you recognize that this guy and this guy are the same thing. One's positive, one's negative. And so I can write my final answer. I'll just kind of clean it up a smidge. 4 sine of x. And that guy would be plus 2x squared sine of x. Now, is that an okay answer? Well, of course it is. I mean, that's the answer. But as I've said before, you're going to have to look at the multiple choice. If they want to make you do more math, they will. What more math step could I do? You say factoring. Of course, I could have a 2 sine of x. So that would be 2 plus x squared. And that is obviously the same thing. So that's why on your homework, I put the answers at the back so that you can kind of always see, do I need to do more work? I don't think I did put the answers on this one. But you kind of look at what they're on Schoology, and you can look at them and see what I need to do more if I need to. So let's try number 2. On number 2, what do you see? You see a quotient. So what are you stuck with doing? The quotient rule. So notice the parentheses. Because if you don't put parentheses there, you probably forget to distribute. So times the derivative of secant, which is secant tangent, d high minus high times the derivative of the bottom. So the derivative of 1 is 0. Derivative of tangent is secant squared over 1 plus tangent of x squared. And once again, for a final answer, I'm going to clean it up a little bit. I'm going to look at my answer choices. They probably would distribute. So that would be, I just distributed this to that parenthesis. So again, that's why the parentheses are so important. And then minus secant cubed. And now let's talk about the denominator. I want to talk about the denominator just because I want to make a point. Remember, when you have trig, you always have in your back pocket trig identities. So when I talk about what more math could they possibly make you do? They could make you use a trig identity. For example, I don't see it in this step, but if I were to multiply this out, like on the multiple choice answers, if the denominator is not 1 plus tangent squared, like it is here, you go, oh, they did something to it. Well, do the more math. Square it out. So if you square it out, I would have 1 plus 2 tangent of x plus tangent squared. And what do you see? Oh, that's when the trig identity hopefully is staring at you at the face. You've got to remember those trig identities. So as a final answer, they could write it this way. I have that whole numerator. Again, could they factor a secant out of that numerator? They could do so many things, you guys. I'm just trying to make a point of you just have to keep doing math until you see the answer that is on the multiple choice. So they could get there. All right, so remember that with trig. Let's go to the back side. The back side is piecewise functions, which we've kind of talked about before. So the good news is it really as simple as, well, if I want you to find the derivative, can I just find the derivative of each piece and go, well, the derivative of him is -2, and the derivative of this is 2x. Can I do that? That part, yes, it is that simple. Now the inequalities, look at what I have here. Is this part that simple? No. And the piece that is not simple is right here. So I want you to write a big star and tell yourself on piecewise functions, check for differentiability at the breaks. Okay, meaning the break on this one is at 1, the break on this one is at 2, because you don't know if that piecewise function, is it going to jump, or is it continuous and it has the derivative the same on the right or left, and is it going to be differentiable? You don't know that. So the inequality, the equal to sign is what I can't be, it won't let me erase that. The equal to sign is what I can't be too picky about. I don't know why it's not letting me erase that little guy. There it is now. So this part I can write, but I have to check for differentiability at the breaks. Now to check for differentiability, the first thing I'm going to do is continuity, because gosh, if I know the function isn't continuous, then I know the function isn't differentiable. So that would be a very easy check. I'm going to plug in 1 here. If I plug in 1, I get a y value of 1. And if I plug in 1 here, I get a y value of 1. Have I proven continuity? Not just by those two things. That proves that the limit from the left and the limit from the right are the same. So it has a limit. Notice that it does have an equal to, which means the function value is also 1. So yes, now I know it's continuous. So I know it's continuous. But can I automatically now say it's differentiable? No. So what do I have to do? I have to do in the same way is the derivative from the left, I would get -2, is the derivative from the right, I would get 2 equal, no they are not, and so I would not put an equal to on that one because this function is not differentiable at 1. It is continuous at 1, but it is not differentiable. So what I have in purple is my final answer. This is my derivative. Notice it doesn't have the equal to sign. So why don't you try 4? On 4, I usually go ahead and do my equations. I know I have 8. I know I have 3x squared minus 4. This one's going to be x is less than 2. This one's going to be greater than 2. But I'm now going to check at 2. Let me check continuity. that would be 0. I plug in 2 there. 8 minus 8, that would be 0. I do have an equal to, so it is continuous at 2. Is it differentiable? Well, 8, the top one I don't plug in anything, so the derivative from the left is 8. When I plug in 2 here, that's also 8. So the derivatives from the left and right are the same. So what does that mean? That means I need to put an equal to on one of those. It technically does not matter which one you put it on. And there's my final answer. That blue is my derivative. All right, last little set. The last little set is when I have absolute values. Now I could do one of two things here. At the beginning of the year and in pre-cal, we talked about rewriting an absolute value as a piecewise function. Well, if we did that, then you'd be back to the example 3, but even easier, because what do you know about absolute values? They're going to have that sharp turn. So you wouldn't even have to check for the equal to because you would know it's not there. But let me suggest, if what's inside here is linear, can I suggest a faster way? I do these graphically. You don't want to make the problems harder than they are. Think about what that graph looks like. Okay? It's a V. Now it's shifted. Be careful. You have to remember some things about pre-cal. I'm not shifting 9 to the right. Anytime you want to get where your turn is, set what's inside the absolute value equal to 0 and solve. So I get 9/2 or 4.5. I don't care how you want to write it. So this graph is looking like this. At 9/2, is it an up V or a down V? Well, it's a positive absolute value, so it's going to be like this. Well, if I gave you that picture and said, guys, looking at that picture, write the derivative, my guess is you could get it. You say, well, I have one derivative when x is greater than 9/2, and I have a different one when x is less than 9/2. These are linear. So the derivative at any point is going to be the slope of that line. Well, you know it's positive. Look at this function. What is the slope of 2x minus 9? Well, I mean, what's the slope part? It's 2. So my derivative for anything bigger than 9/2 would be 2. On this left, when x is less than 9/2, which is him, what is the slope of that guy? What's slanted negatively? Well, it's just going to be -2, and that problem's done. You know it doesn't have the equal to. It's that simple. So why don't you try example 6? All right, pre-cal. I don't have a multiple, so I could tell the shift really easily. It's moved over to the right 3 and up 1. So there's going to be my turning point. Because of this negative, it's going down. And so here we go. F prime of x. I have x, again, doesn't matter which one is on top and bottom. I always do my greater than on top. Just make sure once you establish that, this has to match it. So if I'm saying x is greater than 3, I'm saying to the right of 3, so I'm talking about this line. What is the slope of that line? Well, I know it's negative because it's slanted that way. Looking here, what number's in front of x is 1, so I know that one's -1. And then what is x is less than 3 is this line, and that slope would be 1. And so there you go. That's my derivative. If what's inside the absolute value is not linear, then you're stuck with rewriting it as a piecewise function and then going from there. But if it's linear, you can make it very, very quick. All right? So work on the homework and practice. It has some review problems, in fact, so it'll be good for you. All right? Peace out.